Welcome back again. So now we're going to start using those properties and the Pythagorean identities to simplify these expressions. Okay, part A, 1 minus sine squared. Well, this thing right here is really close to that first Pythagorean identity. Now, the reason why these things are really powerful is because you can move things around from side to side. So like this, you could move over here just like a regular equation. You could subtract it over to the right side. So 1 minus sine squared, that's equal to cosine squared. And that looks pretty simplified. So when they say simplify each expression, you're just trying to get it down to like a single trig function if you can. Hopefully nothing that has a fraction in it, that sort of thing. So you want it to look a lot less complicated than what you're starting with. Okay, tangent of theta divided by sine of theta. So one thing you can do with these, when all else fails, or if you just don't know what to try, you can always try to change everything into terms of sines and cosines. So like tangent, that's sine over cosine, and then you still have your original sine in the denominator. I'm just going to stick it over a 1, because when you divide by something, it's the same thing as multiplying by its reciprocal. So in this case, the sines cancel, and you have 1 over cosine left over. But don't ever leave it like this. If you have a single trig function in a denominator like that, you can always change it into its reciprocal function. So like 1 over cosine would be secant theta. Okay, part C. Let's change them all into sines and cosines. So cosecant 1 over sine. Tangent sine over cosine. And cosine is just cosine. So the sines cancel, the cosines cancel, and we're left with 1. Okay, I'll leave you guys to figure out part D. It's going to be pretty similar to this one. But let's look at part E. So we can use the properties, we can use the identities on these, but we can also use any algebra technique with these. So sine of the fourth minus cosine of the fourth, that actually can factor, and it's a difference of squares. So sine squared minus cosine squared, and sine squared plus cosine squared. And we can't really do anything in the denominator, so we're just going to leave it alone. Well, we can start playing around with this a little bit more. Sine squared minus cosine squared, that's a difference of squares again. So we can factor it one more time. So let's go sine theta plus cosine theta times sine theta minus cosine theta. And then look what we have right here. Sine squared plus cosine squared. Hey, that's that first Pythagorean identity. So this whole expression, this whole term inside that second set of parentheses, that can turn into 1. And then our denominator just stays the same. And now you have something that matches up from top to bottom. The sine theta minus cosine theta. So that whole big old fraction with all those exponents equals sine theta plus cosine theta. And that's all you can do. Okay, now this one looks kind of fun. So let's look at the top on its own and also the denominator on its own. So the top, there isn't really any properties that we can use with these or identity. So we're looking for algebra. And the only algebra I can really do is to pull out what's common. So I'm going to pull off a cosine of A. And we're left with 1 minus 2 sine A. Now the denominator, I have a mixture of cosine squareds and sine squares kind of running around together. So I am going to use an identity with this. So since I have two sine terms, I'm going to change my cosine squared into something with sines in them. And we used that earlier. Now we're just going to kind of use it in reverse. Earlier in part A, we knew that 1 minus sine squared, we can change that to cosine squared. Well, I can always change it back into that if I want. So that cosine squared, I can rewrite it as 1 minus sine squared. And then I'm going to leave everything else alone. Because on the denominator now I can combine things together. Let's leave the numerator factored. In the denominator though, the ones cancel out. And I'm left with sine minus 2 sine squared. So I've exhausted my properties and identities that would be useful. So now let's keep going with the algebra in that denominator. So pull out what's common, which is the sine. And your 1 minus 2 sine A's cancel out. And you have cosine over sine, which can change into cotangent. Isn't that cool? How this big ol' thing right here, this big ol' fraction with sines and cotangents, or sines and cosines, can turn into just cotangent. That is really cool. Okay, let's do this last one and then we'll stop it there. All right, cotangent of A plus all that. Well, normally when you are adding two things together and they're either both a fraction or one of them is, what do you normally do? You find a common denominator. So before I do that though, I want to make sure that I'm dealing with like kind of like the same trig function everywhere. It's a little difficult to work with 3 different trig functions. If you can get it down to 2 functions or just 1, that's usually a lot easier to do. So this cotangent, we're going to change it into cosine over sine. And now I've got something that I can work with. So I'll just sines and cosines, so now I can keep going. So let's get a common denominator, which would be sine A cosine A. So the first fraction needs a cosine, so that's going to turn it into cosine squared. So the numerator, if I add up like terms, that would be 1 minus cosine squared. Sine A cosine A just stays in the bottom. And now I have that Pythagorean theorem, or Pythagorean identity again, but it's a little bit backwards. This time I can move the cosine squared over, so 1 minus cosine squared is sine squared. So now you have a sine on top and bottom, and you have sine over cosine, which is just tangent. And that is just so cool to me too. Again, like these things, they just work down to bam, just like cotangent or just tangent. That's pretty cool. All right, let's go ahead and stop there, and we'll pick it up in the next video.